Very good evening, all of you. Welcome you guys. Welcome you all. So, first of all, do check am I audible or not? Everybody, please comment in the comment sections. So, whether I am audible or not, will you please confirm the audio video clear or not? Please confirm about the audio video. Welcome you guys. Welcome you all. Welcome to the Unacademy, India's largest online education platform. So, I hope all of you are following the previous classes and all. And this is the fourth class on electromagnetic field theory. Excuse me. This is the fourth class. And so, if any of you missed the previous classes and do watch the previous classes, do play the previous classes and come to the live class. Okay. So I will try to make the subject is the best possible way so you can able to easily understand the concepts. Chalo, let's continue our discussions, all of you. And before this, we have a small announcement from the Unacademy. So Unacademy is conducting this All India mock test. With this mock test, you can have a real GATE experience. There you will get to know. So what are your weak points? By knowing the weak points, you can make those points strong by revising the concepts. And you will get to know what are the most important areas for the GATE 2023. And the exams which we are planning on the December 4th, 18th, January 8th, 15th, 22 and 29. So you can enroll for this test. The test is completely free of cost to all the students. You can enroll for this Unacademy All India mock test by using a code of BV Reddy. By using a code of BV Reddy and do enroll for it, you will have a great experience with this. Chalo. And so we can plan the Unacademy subscription without paying any additional charges. With a no cost EMI you can plan it. And Unacademy, this complete class notes are available in the website. You can able to access all the materials. So the digital notes are available. And these are the new batches we are starting. You can find the top educators of India. You can find there. Each and every topic will be covered in detailed manner. So for the GATE 2024, we have started the new batches. That is from November 24th on started. Adityas has started the new batch. You can use a code of BV Reddy to enroll for this course. And this is for electrical. These are the new batches we are starting for 2023. And you can follow this battle and you will get to know where you stand. And these are the Unacademy test series. And these are the features of Unacademy Plus. The Plus students will get the top educators will take the classes and digital notes and test series. In addition to that, so iconic students will get additional benefits of customized doubt solving feature and printed notes, hard copies available, and one-to-one mentorship, strategy and study program, and interactive open house sessions. Chalo, let's continue our discussion, all of you. In the last class, yes, we have discussed about the divergence concept. हमने डिस्कस किया. Tell me all of you, ये सारा टॉपिक हमने डिस्कस किया. अगर यहाँ तक अगर आपको कोई डाउट हुआ तो बोलो. जो हमने डिस्कस किया यहाँ तक, if we have anybody have any doubt in these topics, do let me know. Yeah, so here, so right now we are not come to the problems discussion here. I told you now, so here for the problems and material, so here we have the telegram group. You can send the message to me in the telegram group, so you will get the complete dpp आपको मिलेगा. And or what we can do here, Unacademy. So there you can have a community section is there now. In the community, there you can get the, so you can follow the community. In the community, I will share all the things. There we have discussed each and everything we have covered. The material, the class notes, the running notes is there now. Those also will be provided there. Okay, fine. So here gradient का physical meaning. Look at now here, gradient means generally gradient operations. For example, let us consider we have some level surface. We have some level surface. If we have considered, so here let us consider here. Consider for easy understanding visualization purpose one-dimensional manner. Let us consider we have. Let us say this is, and consider, and this direction, if I move, this direction is x direction and this direction is y directions, right? If you see carefully now here, now along this direction if I move, that means along the y directions, due to find the change here, you tell me, do we have any change of the physical function? We have a change which is along the y direction is there. Yes or no? We can call this as the variation of this function with respect to y. Variation of this function some v with respect to y we have. And can you tell me now here this variation which is what direction? You tell me in this direction now. In this direction we have a maximum, and this will gives what you tell me now here, the rate of variation, the rate of change of the given function with respect to y, with respect to y. And for example, let us consider the temperature. Let us consider temperature. Now temperature, just assume that which is the function of x value and y value, consider here x and y, two-dimensional manner. Now horizontal motion we have taken as x direction, and the vertical motion I am calling it as a y directions. Vertical motion is y direction. If we see carefully, the variation of temperature now from this point to, if I move 1 kilometer distance horizontally, if I move a distance of 1 kilometer horizontally, and so can you tell me now what is the change of the temperature with respect to x? What is the variation of the temperature with respect to x we have? Did you find any much difference if I move horizontally 1 kilometer? Did you find any change of this temperature horizontally? We cannot observe the much difference now. It is almost equal to 0. Isn't it, all of you? Whereas if we have moved the vertically, if I have moved the vertically, that means along the y directions, did you find the variation of temperature is there or not? We have the variation of temperature which is definitely non-zero. As if I move vertically, there is a temperature variation we have definitely. But whereas along horizontally, if we move from here to 1 kilometer distance, you cannot find the much change. So that means what I can say now here, the gradient of this function temperature, that means del v, what it will signify, you tell me now what I can say, which is equal to 0 into ax cap, x direction 0, whereas y direction something is there now, that means something we have, let us say whatever it may be. So here something here, that is dou t by dou y, which is non-zero parameter, which is along the y direction. What is the signifies, you tell me now here? That means along horizontal motion there is x direction, there is no change. But whereas along the y direction if I move, there is a variation you can find, isn't it? If I call exactly, so what I can say similarly, if I call my some function, the gradient of some function, if I call something del f, if I call, which is equal to something 2 into I cap plus 3 into j cap plus 4 into k cap. Let us consider I have given some randomly. What is the meaning of this? Means what now here? So that means, so this the magnitude of change of this function f, the magnitude of change of this function along the x directions, along x direction, how much you tell me? That is 2. The magnitude of change along the x direction, it is 2. To what's the meaning of this is, for every 1 meter distance there is a change, you can find the 1 unit, it will be observed 2 times, 2 units will be changing. And if I say this thing along y direction, so for every 1 unit along the y direction there is a variation you can find in the y direction is 3 units. And for every along the z direction, for every 1 unit change along the z directions, there is a change you can observe, the 4 units you can observe, isn't it? So the same manner, if I have given some other function, let us consider here del g, if I given this as something here 2i, let us consider here minus 3j if I given. So what's the meaning of this is, the function g, the function g, which is how the variation you can observe now here, along the x direction it is increasing by 2 times, but whereas along the y direction it is decreasing by 3 times, isn't it? So that is a physical understanding. We need to know the variation of the physical phenomena with respect to the space parameters. The variation of the physical phenomena with respect to the space parameter is the gradient operations. Is it fine, all of you? Done. In the last class we have understood the concept of divergence function, we understood, right? So how we can do the divergence of a vector, you tell me? How we can do the divergence of a vector? The divergence of any vector function, how we can calculate, you tell me? How we can find the divergence of any vector? So if I say del dot, here we are calling this A is a vector. Divergence will indicate as like this, now tell me. And which is given as dou ax by dou x, yes, plus, and dou ay by dou y, plus dou az by dou z. All of you boliye. This is the divergence calculation. What is this ax now here? Basically the vector a, how it is, you tell me? It has a x component now, that is called as ax. Yes. Divergence we operate on a vector quantity, whereas resultant of divergence is a scalar quantity. Resultant of divergence is a scalar quantity. Right? Fine. Chalo, let's see now here, next one here. Curl of a vector functions. Let's try to understand the curl of a vector function. The curl of a vector function, it will signifies what? It will signifies how much field rotating about the given point. It will signifies the how much field rotating about the given point. Let us say here is a point we have taken. This is the point P. If I consider, it will give the nature of the rotational field. How much field which is rotating, it will be signifies the curl of a vector quantity, right? Now, fine all of you. In general, so this curl of a vector quantity, curl is operated on a vector quantity. The curl of a vector quantity, it may be a positive and it may be negative also, and it may be zero also. Curl may be positive, negative and zero also. And the curl of a vector quantity which is positive in case of a anti-clockwise rotation. Anti-clockwise rotation, curl is positive, and in case of a clockwise rotation, curl is negative. And zero means what now here? If there is no rotation, or so net rotation is zero, means clockwise rotation equal to anti-clockwise rotation. That means net rotation is zero. Fine all of you. This is the curl of a vector quantity. Now, let's see how we can find the curl of a vector quantity. Rotation of a field, it may be electric field here. So as of now, basically curl we can apply general word, that is, and in our electromagnetics fields we will apply the curl for the electric field, magnetic field. So basically the divergence, gradient, divergence, curl, are these are the can be applicable for anything. Any vector functions can be applicable. Any vector scalar function we can apply. And specifically here in our subject we wish to apply for electric field, magnetic field. Don't say this will be applicable. We wish to apply only for the electric and magnetic field. So you can apply for any vector. We can apply the curl and divergence. Right. And coming to here. Now how we can find the curl of a vector, you tell me? That is del cross A. And which is given as what, you tell me? So this is my Ax cap, Ay cap, Az cap. And dou by dou x, dou by dou y, and dou by dou z. Next, Ax, Ay, Az. This is a curl of a vector. Determinant. I hope all of you know how you wish to expand the determinant. How we wish to expand the determinant of सभी को क्या था ना बोलिए? Right. चलो. चलो next one. Is it fine all of you? Next. Laplacian of a scalar function. The next one is a Laplacian of a scalar function. The divergence of gradient of a scalar function. Divergence of gradient of a scalar function is defined as a Laplacian. Divergence of gradient of a scalar function is defined as a Laplacian of a scalar functions. Means what, you tell me now here? Divergence means del dot. Divergence of gradient means what now here? Del V na. The divergence of gradient of a scalar function which is defined as a Laplacian, given as what? Del square V. del square V, where this del square which is Laplacian operator, which is called as what? Laplacian operator. Del square is called as what? Laplacian operator. And the del square, which is given as second order differentiation, that is dou square by dou x square plus dou square by dou y square plus dou square by dou z square. This is second order differentiation like this. Dou square by dou x square, dou square by dou y square, and dou square by dou z square. Fine, all of you? Right. Del square V equal to 0. This is called as a Laplacian equation. This is called as a Laplace equation. Del square V equal to 0 is called as a Laplace equations. Right. Now, if any function satisfies Laplace equation, then that function is called as a harmonic function. Then that function which is called as a harmonic function. If any function satisfies Laplace equation, here this V is called as a harmonic function. If any function satisfies Laplace equation, that function is called as a harmonic functions. Right. The divergence and curl in the cylindrical system and spherical systems. The divergence and curl in the cylindrical system and spherical system I'll give you. So, and all of you listen carefully. Divergence and curl in the cylindrical systems. And if you see carefully divergence and curl in the cylindrical systems, so these formulas आप ध्यान से देखना पड़ेगा. So Cartesian system we have seen. Now tell me all of you, Cartesian system we don't have any problem, isn't it? So that is del dot A, and which is given as what? You tell me Cartesian system, tell me divergence is a, that is dou Ax by dou x plus dou Ay by dou y plus dou Az by dou z. So basically, so these formulas in the cylindrical and spherical systems are, these are little complex. अगर स्टार्टिंग अगर आपने ये फॉर्मूलाज देखा तो आपको डर लगेगा, इसीलिए so here I plan to discuss this thing wherever the things required at that instant I am planning to discuss. Right? Coming to in the cylindrical system, all of you ध्यान से देखो. Cylindrical system, what are the parameters we have? Tell me everybody first of all. Cylindrical system, what are the parameters? Yes, we have rho phi z. All of you tell me rho phi z. Del dot A, which is given as, try to remember the first function, 1 by rho dou by dou rho of rho into A rho. All of you this thing, first thing. Next, 1 by rho into dou A phi by dou phi plus dou A z by dou z, right? This thing. This is the divergence in the cylindrical systems. So first one, try to remember this thing. अगर आपने ध्यान से देखा तो इधर, so can I cancel this row and this row? Is this row and this row, can I cancel it here? No. Remember this thing. These two rows we should not cancel it. All of you? Right. Coming to the spherical system. Divergence in a spherical system. She is given as 1 by r square into dou by dou r of r square into ar plus 1 by r sin theta into dou by dou theta of sin theta into a theta plus 1 by r sin theta into dou a phi by dou phi. बोलिए. This is the divergence in the spherical system. Harmonic function. So here simple example, if you have, you will get to know. Wait, so here first of all, is this clear? Tell me everybody. First of all, is it clear? Tell me all of you. So here first of all, this thing divergence, all these things are clear, right? And now let's talk about the curl in the different coordinate systems. Curl, we have seen the Cartesian system, we have seen curl, we have seen Cartesian system. Now let us talk about the curl in the cylindrical systems. Let us talk about the curl in the cylindrical system. All of you listen carefully. All of you listen carefully. Cylindrical system, can you tell me what are the unit vectors we have? Tell me. What are the unit vectors in the cylindrical system? A rho, and this is A phi and AZ. A rho, A phi, AZ. And so what is a del operator? Tell me. Dou by dou rho 1 by rho into dou by dou phi and dou by dou z. And then vector which is given as A rho, A phi, AZ. All of you tell me this thing. Everybody, this is the curl in a cylindrical system I have written. All of you look at here, everybody. Is it fine? Tell me all of you first of all. Is it fine? All of you tell me there. बोलो यार, हाँ ना बोलो. आप सभी ने कॉपी किया कि नहीं यहाँ तक? Is it clear to everybody यहाँ तक मैंने जो डिस्कस किया? Now, अभी देखो इधर. So here we are going to do one small magic I want to do. Here I am going to do some magic I want to do here. Listen carefully. What's the magic I want to do here? All of you ध्यान दो इधर. I have multiplied with rho. एंड डिवाइड विथ रो। कोई प्रॉब्लम हुआ बोलिए? मल्टीप्लाइड विथ रो and divided with row. Everybody try to maintain the interactions, and starting class 1 onwards I'm saying here. So the interaction is very important. हमको पता होना पड़ेगा. So here whether you following or not, I have to know. तभी तो here हम अच्छे से डिस्कस कर पाएगा ना. देखो इधर मैंने ये मल्टीप्लाइड एंड डिवाइड ऐसा किया. अगर आपने ध्यान से देखा तो हियर नाउ व्हाट आई एम डूइंग इज इन दिस कॉलम कैन आई टेक आउट द 1 by row outside. इन दिस कॉलम कैन आई टेक आउट दिस 1 by row outside. बोलिए अगर मैंने 1 by row बाहर ले लिया तो इधर क्या बचेगा बोलिए? इसको हटाना पड़ेगा, इसको हटाना पड़ेगा. देखो इधर अभी देखो इधर, अभी देखो इधर. सो दिस थिंग आई टोल्ड यू द मैजिक, आई टोल्ड यू ना यही था हमारा मैजिक. दिस इज द मैजिक. दिस इज अ कर्ल इन व्हाट सिस्टम यू टेल मी? Cylindrical system. So magic completed. मैजिक ओवर, मैजिक ओवर. आप सभी को शॉक लगा मैजिक देख के? हाउ यू आर फीलिंग अबाउट दिस मैजिक? आप कभी भी मैजिक ऐसा मैजिक देखा क्या? हैव यू एवर सॉ दिस टाइप ऑफ मैजिक पहले? So here the best magic secret. And this is the cylindrical system. Abhi bolo, now let's talk about the spherical system. Where you have seen this magic, yeah? That what we did ना. मुझे multiply किया, divide किया. That's all. Multiply किया, divide किया. So इसको बाहर ले लिया ना. That's all. Magic over. Magic over. प्रशांत किधर देखा यार मैजिक? Right. Now see this thing. Let's talk about the curl in the spherical system. Let's talk the curl in the spherical system. Now tell me the spherical system. What are the unit vectors? You tell me first of all. That is A r cap, A theta cap, A phi cap. These are the unit vectors, right? Next, tell me the del operator. Tell me here. So which is given as dou by dou r. Yes, so here 1 by r into dou by dou theta, 1 by r sin theta into dou by dou phi. बोलिए this thing, all of you. Next, thereafter here we have A r, A theta and A phi. Done. Yes. Over or not? Tell me first of all. Is it completed or कोई बचा इधर? Yes, everybody done. कोई बचा इधर? तो क्या बचा? बोलिए. हाँ, क्या चाहिए इधर आपको? बोलिए अभी. क्या चाहिए आपको अभी? मैजिक क्या चाहिए? मैजिक चाहिए क्या? व्हाट यू वांट यार? व्हाट यू वांट? क्या चाहिए आपको अभी? मैजिक. सो हियर कल्याणी, व्हाट यू आर थिंकिंग अबाउट मी यार? What you fellows are thinking about me? I am a teacher or magician? What you thinking about me? Am I a teacher or magician? What you thinking about me? How you are expecting? How you are expecting from me? Magic and all. So I am not a magician, right? Hmm. What you expecting? Fine. So as per you fellows kind request, as you as your kind request, so I am doing the one more time magic I am doing. So here, as per your kind request, I am doing one more time magic, and do remember this. I won't repeat the magic again. I won't repeat the magic again. All of you ध्यान से देखो. देखो इधर. I am multiplying and dividing with R here. Multiplying and dividing with R here. Yes. Next, multiplying and dividing with R sin theta. Multiplying and dividing with r sin theta. Here also r sin theta से multiply किया, divide किया. Multiply and divide with r sin theta. Now you tell me now here, from this column I can take out 1 by r outside. From this column I can take 1 by r sin theta, I will take outside. So then total what is outside, you tell me? 1 by r square sin theta. Done. So I should remove this 1 by r here. I should remove here. I need to remove this thing here. I have to remove this thing. I have to remove this thing. Isn't it? All of you tell me. सभी को आया कि नहीं बोलो? आया कि नहीं सभी को बोलो? So this is a magic. So this is the curl in a spherical system. This is in what system? Spherical coordinate system. Done? Done. Everybody. So here a magic ko here, this is a magic, the same thing in your mass. In the mass we studied, so which we used to call this coefficient is called as a Jacobian. आपने सुना? Jacobian. Have you heard the Jacobian? This coefficient is the Jacobian in your mathematics we used to call. Here I am simply giving the trick to remember. The simple trick we are doing, isn't it? Now what we can do in the exam also, you can do like this. Fine? Chalo? This thing. Shall we move the next one here? All of you boliye. Done. Now let's move the next topic, that is a vector theorems. Vector theorems. So take the first one is a Stokes theorem. Vector theorem. The first one is what you tell me? Stokes theorem. Listen carefully. Listen carefully. Stokes theorem. Let us consider, I want to find the closed line integration of some vector. Closed line integration of vector A dot dl I have to find. So here, so this thing here, so I do remember the same manner, yeah, like a magic. First you write the things and do the magic. And first write and do the boom boom shakalaka. Magic karo. Okay. so that you can easily remember. So write the 1-2 times here, then obviously आपको स्मरण होने वाला, and we'll do so many problems we'll do on this thing, तभी आपको पता चलेगा. So automatically आपको दिमाग में ये घुसेगा. You never forget the things. Don't worry. Now, right. Now let us consider I have taken some closed path like this. Now, let us say this is my some closed path. I want to find the integration of this vector along this closed path. So here this closed path contains how many lines? You see this thing, how many open lines? You tell me. This closed path will contains how many open lines? You tell me, all of you. How many open lines will contains? You tell me, all of you. So this is the first line, and this is the second one, and this is the third, I can say, and this is the fourth one. For example, in general, if we want to do this integration of this vector, what we should do here? The first path integration of A dot dl. First path integral of A dot dl plus, next what we can say now here, second path integration of A dot dl. Second path integral of A dot dl plus third path integration of A dot dl plus fourth path integration of A dot dl. Isn't it? This is what we need to do basically. Hana boliye. This what we should do basically. So to find this one here, we need to do the 4 integrations we need to do. Yes, but as we know this, we are very lazy fellows. As we know, we are very lazy fellows. Right. So who will do these many integrals now here? So as we know that, so this is my closed path. This is my closed path, right? And अगर आपने ध्यान से देखा तो here this closed path will forms what? This closed path will forms what, you tell me? This closed path will forms what, you tell me now? Open surface. This closed path will forms what, you tell me? Open surface. Arrow की direction किसी भी, yes, we have randomly taken here. Here we have taken randomly had taken. So don't be specific about the directions. I have randomly considered something. Yes, whatever it may be, I have taken. Either you consider clockwise, you consider anti-clockwise, you consider. कोई problem. I have taken randomly to explain the in the how you need to apply the Stokes theorem. I have taken randomly. Okay. This closed line will form an open surface. Based upon that property, what I am doing is this closed line integral I am converting into a open surface integral. That is how it is a this closed line integral of A dot dl is equal to open surface integration of del cross A dot ds. Del cross A dot ds. Is it fine, all of you? Closed line integral of A dot dl, which is equal to open surface integral of del cross A dot ds. This is the Stokes theorem. Instead of finding these many integral, we have 4 integral. Simply find the del cross A and do the open surface integral. That is answer. Fine. So by using what we can do here? By using Stokes theorem, we can convert the closed line integral is converted to open surface integral, and vice versa. Closed line to a open surface integral and open surface to the closed line. Right. Next. divergence theorem. Divergence theorem. See this thing here. So if I have a closed surface integration, we have the closed surface integral of A dot ds. Let us say the closed surface, and which is given as like this. Consider we have some closed surface like this. Consider some cube. ऐसा मान लिए. This is my closed surface. This is my closed surface. Now this closed surface, I want to find how many surfaces, how many open surfaces it will contain. You tell me how many open surfaces it may contain. You can see now here. I can say top open surface now here. Top open surface of A dot ds, isn't it? Plus what I should write now here? Bottom open surface of A dot ds. All of you बोलिए. Plus I can say left open surface of A dot ds plus right open surface of A dot ds plus the front open surface of A dot ds plus back open surface of A dot ds. Tell me all of you. So these many open surfaces we have, isn't it? Now here, instead of finding this six open surface integral, what we are going to do here, this all these open surfaces we have converting as a single now here. How it is, you see. The closed line in surface integral of A dot ds, which is equal to, now you see this thing, this is the closed surface, and the closed surface will have what, you tell me, volume. Closed surface will have a volume. Now tell me all of you. So what I can do, this closed surface integral I am converting into a single volume integral as like this. So that is, so here that is del dot A into dv. This is the divergence theorem. So by using this divergence theorem, we are converting the closed surface integral is converted to the volume integral and vice versa. Right? So here actually, so this divergence theorem and Stokes theorem, these are the theorems. Divergence theorem and Stokes theorem, these are the two theorems we have, isn't it? Now you know here. So yeah, so what we can do to prove this thing, we'll take the example we can do and we'll prove this thing here. LHS is equal to RHS. Okay, so that is a way we need to do it now here. We have a separate theorem is there, and this theorem you must studied in your so you have studied a Green's theorem in the mathematics. You have studied a Green's theorem, might be that Green's theorem is nothing but the Stokes theorem only. That Green's theorem is nothing but two-dimensional case, we'll call that as a Green's theorem. Three-dimensional case, we'll call that as a Stokes theorem. Okay. Right. Is it fine, all of you? Divergence theorem and Stokes theorem. Fine, all of you? चलो हम और बोलिए. चलो next one. Now अभी तक हमने पूरा, so here the basics for to learn the electromagnetic fields we have discussed the coordinate systems and the vector calculus हमने अच्छा से किया, isn't it? Now let's move some of the important analysis we are going to see. all of you ध्यान से देखो, some important points, listen carefully, make a note, all of you, everybody ध्यान से सुनिए इधर. Now you tell me now, if the divergence of a vector is 0, if the divergence of vector is 0, then what will call that vector is a, if the divergence of vector is 0, then that vector is called as what? Then that vector is called as a solenoidal. If the divergence of vector 0, then that vector is called as a solenoidal vector. Solenoidal vector, and which is also called as a divergence free vector. It is also called as a divergence free vector. Dimensional means what you tell me now here. Two-dimensional case, it is what now? Vector here A is equal to, in the form of a, if I have this as a 2i plus 3j, if we have, this is called as a two-dimensional vector. This vector which is along only x and y directions only, this is the two-dimensional vector, 2D case. Okay, if we have a 2x into ax cap, if we have, plus 3y square x into az ay we have, this is called as a, this vector has only components along x and y direction. In this case we have this theorem, this that theorem is called as a Green's theorem. If the vector is contains the z component also, that is 2x into ax cap and 3xyz into ay cap plus something here 4z into az cap, if we have like this, so this, in this case we'll call this as a Stokes theorem. In this case this vector if we have, then we'll call this this vector which is called as a Stokes theorem. This is in this case which we used to call the Stokes theorem, isn't it? Right. Now, so if the divergence of vector 0, then that vector is called as what? Solenoidal vector, divergence free vector, also called as a continuous vector. Continuous vector is called as solenoidal vector, divergence free vector, also called as a continuous vector. Next, if curl of a vector is 0, if the curl of a vector 0, then that vector is called as a irrotational vector. Then that vector is called as a irrotational vector. Irrotational vector, conservative vector, which we can also call this as a curl free vector. If the curl of a vector is 0, then that vector is called as a irrotational, conservative and curl free vector. So here you need to focus about the word of conservative. What is meant by conservative vector? What is meant by conservative vector? Means a vector whose line integral is independent of the path. Independent of the path of selection or path of movement is called as conservative vector. Okay. A vector whose line integral is independent of the path. If it is independent path of selection, then we can call that vector is called as a conservative vector. That vector is called as what? Conservative vector. Fine. What's the meaning of this conservative means? Let's try to have some, what is the physical meaning here? Consider we have some vector. I want to find the integration of one vector. Let us say I want to find the integration of this vector, line integration along the some path dl. Let us consider here this path. So this is L is now here A to B. To find the integration from A to B, I can move directly, I can move in this path. I can do this thing here, this path, and here which we are calling this thing as this, I am calling this thing as a, let us assume this is calling as a first path. Now same thing here, we have starting point is A, ending point is B. This is A and B. To find the integration, I can move like this, I can move, right? This I am calling it as second path. A is the initial point, B the second final point. So what I can do here, this I can indicate this thing as second path integration of A dot dl. Second path integral of A dot dl. Next, some other case, let us say A to B, I have to move here, A to B. While moving from this A to B, what I did, the path movement here, like this I moved. Like this. Here I have moved my wish. Yeah. Vikesh, so you have some physics knowledge. So this physics knowledge you can utilize. So I am moved like this. This is my path. This I am calling it as a third path. Yes, I think you might be by hearted the things now. Conservative field work done is 0 and all. So why it is 0 and how it is 0, here you will get to know. So here इसमें आपको पता चलेगा why it is 0, how it is 0 and all. What is the meaning of conservative field, you will get to know. Now here you see this thing here, this path integration, see this thing here, third path integration I can say na A dot dl. Now if you see carefully in all the three paths, now tell me now here, initial point, final points are same or not? Initial point, final point, both are same. And the same vector A. Initial point, final points are same. If the vector is a conservative vector, it does not depends upon the path. It does not depends upon the path. It depends upon what you tell me. Initial point and final point only depends. It depends upon the initial point and final point. अगर आप ध्यान से देखा तो in all the three cases, initial point, final points are same or not? All these cases, initial point, final point same na. So that's why this value of integral also barabar, exactly same. If the initial point, final points are same, the value of this integral is also exactly same. Is it fine, all of you tell me? Is it fine? Tell me here. All these values integral. So here whenever they ask him to find the integration, you may choose directly straight away path, and you may choose this path, or you may choose this path like this. Now here all the cases the answer you will get the same thing, since the vector is a conservative vector. This property, special property, this special property valid only for the conservative only. Yes, depends upon initial and final points. Now अगर आपने ध्यान से देखा तो here tell me now here what is this close if the vector is a conservative vector. Let us see here. I am calling this thing as, let us say A is a conservative vector. If I call A is a conservative vector, I am calling, if A is a conservative vector, now you tell me close line integral of A dot dl, what you will get. If the vector is a conservative vector, close line integral of A dot dl, what you will get. What is the value of this thing if the vector is a conservative vector? Tell me. Yes. Now here look at now. Vector is a conservative vector. Here the path is what type of path, you tell me now? Closed path. What is meant by closed path, you tell me? What is meant by closed path, you tell me? What is meant by, if I started at this point A, I need to again come back to the same point, you tell me? That is called as a closed path. Hana boliye. Wherever you have started, so then you have come back to the same point, you have come back, so that is called as a closed path. ना here अगर आपने देखा तो इधर you tell me now here closed path means upper limit and lower limit both are same. Now tell me, upper limit and lower limit both are same. Yes sir, no, initial point final point same means upper limit and lower limit and upper limit both are same na. If the upper limit and lower limit both are same, then what is the integral value? 0 होगा. बोलिए this thing. Done. Upper limit, lower limit and upper limit both are same. Fine. Right. These two are very important point. All of you remember this thing. If the divergence of vector is 0, then that vector is called as a solenoidal. If the curl of a vector is 0, then that vector is called as a irrotational or conservative. Fine? Yes. The next one. Next one. So in general, yes, the divergence of curl of a vector, the divergence of curl of any vector is what? The divergence of curl of a vector, the divergence of curl of a vector. Suniye all of you, suniye all of you. Listen, here is another important thing. Here A is a vector quantity. Listen carefully. Vector, as we used to write now here, any function can be expressed as sum of even function and odd function. बोलिए, any function can be expressed as sum of even function and odd functions. बोलिए. Yes, like the signals and systems we will study now, even function or even signal, odd signal. It has a combination of even signal and odd signal. Exactly similar to that, any vector we can split it as, we can consider the vector generally will contains, it has a diverging part of a vector and plus it has a rotational part of a vector. You can visualize the vector also will contain the two natures. It may contain diverging nature, rotational nature. Some part may contain divergence, some part may contain rotational. It may not contain anything also. The divergence of a vector and rotational part of vector. Is it fine? First of all, tell me. Here, what is the ED stands for here? What is this ED? ED which stands for the amount of vector having only diverging nature. What is this ED stands for here? All of you dekho idhar. This is what you tell me, this part having only diverging nature. And this ER stands for what nature you tell me? Rotational nature or the curling nature. Fine everybody. Now अगर आपने ध्यान से देखा तो so here if I find the del cross A, what it means you tell me? Del cross A, if you do it now here, it means what now here? It will use the vector having what nature? It is signifies what you tell me, it will use the amount of vector having what nature you tell me? What I want, what we are finding here, देखो इधर कर्ल we are finding means आपको क्या चाहिए? रोटेशनल नेचर चाहिए and diverging nature चाहिए. Tell me. It is having rotational. If I do this thing here, what you will get now? I will get ER बोलिए. If you do that one, I will get ER. हाँ बोलिए बोलो. If you do this thing, I will get AR. बोलो. Isn't it? Now you tell me now here, after getting this thing here, I got this thing. We got this thing, we got. Abhi dekho idhar. So what we are doing now here, that is I want to get the del dot of del cross A. I have to get now. Agar if you see this thing here, this is del dot of del cross A. We got as what you tell me AR. Del yes. Got it now, del cross A, we got it as AR. Now you tell me now what is this AR is a? What is this AR is a? That is the amount of vector A having what nature? What nature it will contain, you tell me? That is only rotational nature. That is the amount of vector having what natures? Only rotational nature. I am finding the divergence I am finding. That means what you tell me? I need what nature is required. Nature I required, you tell me. What nature I required, you tell me now. I am calculating divergence, calculating. Means what I want. Diverging nature is required or rotational nature is required? What are required now? Diverging nature. Is this vector AR, will it contains any diverging nature? Will this fellow is what nature contains? You tell me this part completely. It contains completely rotational only, na? It does not contain diverging. Hana boliye. So then as a result, what is the diverging nature of rotational part? This part will become 0 boliye. So this value to 0. Hana bolo this thing. Yes, सभी ने जोर से बोलो एक बार. ये समझ में आया कि नहीं? So that's the reason the divergence of curl of any vector. The divergence of curl of any vector is always 0. Write in words also this point. Curl of any vector is what you tell me now, always 0. पहली बार समझा नहीं तो पहले तो बस। अरे यार हिमांशु आपने क्या बोला आपने हाँ सो किया आपने क्रिटिसाइज किया प्राइज किया मुझे समझ में नहीं आ रहा। राइट, इज इट फाइन ऑल ऑफ यू टेल मी? चलो next one here. Similar to that we have one more thing we have. Similar to that we have one more equation we have, that is the curl of gradient of any scalar function which is always equal to 0. The curl of gradient of any scalar function which is equal to what? 0. The curl of gradient of any scalar functions. The curl of gradient of any scalar function which is always equal to 0. This is another important relations. And this relation also you might see in your mathematics also this thing. Yeah. How we can write the word statement? The curl of gradient of any scalar function is 0. The curl of gradient of any scalar function is what you tell me? 0. The curl of gradient of any scalar function is always 0. Done? Everybody? Chalo? Next. The next point. All of you ध्यान से देखो. See the equation 1 and equation 3. Equation 1 and equation 3. See the first equation, tell me. ये भी important है. देखो इधर. We are finding this thing here. What is this V here? What is this V here? What is this V here, yeah? What is a gradient of a scalar is a? That's what I'm saying. Suniye, I understood your doubt. What is a gradient of a scalar is a? Gradient is of a scalar is a vector or scalar? Gradient of a scalar is what? Vector, scalar. Is a vector. So this is a vector function. This whole thing is what we can say now here. This is a vector function. All of you tell me. This whole thing is a vector function. Now you tell me now here, what is the curl of a vector functions? curl of a vector function, what I will get? If you find the curl of a vector function, what you will get? The curl of a vector function, what it will give? The curl of a vector is a vector scalar. Curl of a vector is a vector scalar, is a vector quantity. So इसीलिए मैंने 0 bar लिखा. So this is here strictly speaking, which we will call this as a null vector. The curl of a vector is what? Vector quantity. So that's why 0 bar. Fine. Done. Hello? Right. Now let's see the next one here, fifth point. Tell me here. Now see the first equation. See the first equation. If equation 1, remember here, if the divergence of vector is 0, then that vector is called as a, if the divergence of vector is 0, then that vector is called as what? You tell me. That vector is called as a solenoidal vector, right? That vector is called as a solenoidal vector. Now you tell me, third equation, tell me what is the third equation we have written? Third equation, what we have written? The divergence of curl of any vector function is what? You tell me 0. The divergence of curl of any vector function is what? 0. देखो इधर. Now can I compare these two equations here? Can I compare this equation and this equation? Here we have divergence here. Here we have 0 is there. Can I compare these two terms here? By this comparison, what I can conclude? You tell me now here. I can write this B as what I can say now here? Del cross A. I can write the B as a del cross A. बोलिए. I can write this B as a del cross A. हाँ ना बोलिए. Everybody, B is equal to del cross A, I can say. Now here the thing is, अगर आपने ध्यान देना पड़ेगा, what is this B here? What is this B here? Tell me. What is this B here? B, which is called as what? To tell me. Where B is what? Where B is a solenoidal vector. Where what is the B here? B is a solenoidal vector. Hana boliye. B is a solenoidal vector. Isn't it? B is what type of vector is a? We can't say it is a rotational. It may not have a rotational. Yeah. अगर देखो इधर सुनिए. If I say divergence of this vector, I call it as 0. Will you give guarantee about this vector is a rotating? Will you give guarantee that this vector is rotating? We cannot say. It may have the divergence is 0. It may be curl may also may be 0. Now how we can say it is a rotational vector? So from that del dot B is equal to 0, from that what we can say? I can talk about I can talk about only diverging. I can comment. I don't know this equation of whether it is 0 or not. हमको नहीं पता. Then how we can decide it is a diverging vector? We can't say na here. We can't say here. From this equation, I have written this equation. From this I can say about the only this vector is only, it is not diverging. It may be rotating or not, हमको नहीं पता. Isn't it? All of you tell me. Now what is the B vector here? B vector is a solenoidal. So that means what we can say here? What we can say? Here I have taken this example is some B is some random vector. You may have in so many vectors, we may have this type of natures, isn't it? del dot b is equal to 0. अगर del dot b is equal to 0, that vector is solenoidal. Any solenoidal vector, if the vector is a solenoidal, any solenoidal vector, I can express this thing as like this now here, the curl of some other vector. If that within that vector is a solenoidal, that solenoidal vector I can write this thing as a curl of some other vector. हाँ ना बोलिए. So from this what you can say now, tell me. From this what we can conclude, you tell me now here. Any solenoidal vector. So what we can say now here, any solenoidal vector can be expressed as the curl of some other vector. Try to understand the physical meaning of this. Yes, अरे यार b जीरो आई तो क्या फायदा यार b. हाँ, so यार b जीरो आई तो क्या फायदा, b should be नॉन जीरो होना पड़ेगा ना. अगर b जीरो आई तो then why we can go for the some other, tell me. You will no need to find the divergence now. B is some vector, b is some non-zero vector. It should not be a zero. If it is zero, क्या फायदा. ये पॉइंट आपको समझ में आया कि नहीं, बोलो इधर एक बार पहले. Any solenoidal vector can be expressed as the curl of some other vector. Is this point clear? You tell me everybody. इसमें कोई डाउट हुआ तो बोलो. Any doubt in this point, tell me. Parallel and rotational both are same. Is it fine? Done. Now you see the next one here. Now see the second equation. If the curl of a vector is 0, if the curl of a vector is 0, then that vector is called as what, you tell me, irrotational and conservative. Irrotational or conservative we can say. Now tell me see the fourth equation. And what the fourth equation we have? The curl of gradient of any scalar function. The curl of gradient of any scalar function is 0. So from this, can I compare this thing, tell me? Can I compare this thing here? I can write this thing as what I can say, tell me now. A is equal to, I can write this thing as a del V. A, I can write this thing as what you tell me now here, del V. A equal to del V, right? And here what is this A, tell me? What is this A? A must be conservative. What is this A, tell me? A must be conservative. A must be a conservative vector. Then only the curl is 0, then only I can compare these two equations. Then only I can conclude this equation, or tell me. So here to write this thing here, A must be a conservative vector. So from here what we can conclude, you tell me now. Here what we can conclude, you tell me now here. Says any conservative vector can be expressed as what, you tell me? the gradient of some other scalar function. Any irrotational vector can be any rotational conservative, you can write anything, so can be expressed as gradient of some other scalar functions. Is it fine, all of you? Tell me, is it fine everybody? इसमें कोई डाउट हुआ तो बोलो इधर यहाँ तक. Is it fine everybody? Done. This thing. Yes, all these 6 points we have seen. You do remember these 6 points we use in our subject. आगे हम use करेगा. You will see this, all the 6 points, the physical meaning also you can see. Whatever we used to see here. If you know this thing here, in your maths also you might heard about the things now here that is called as one term that is called as. Have you heard about the vector potential, scalar potential in your maths? Have you heard about the vector potential and scalar potential? Those concepts came from here only. The concept of vector potential, scalar potentials has originated from these topics, right? And we'll see this thing in our inside our subject. जाने के बाद we'll see here. You will get to know. Here this V is there now. This is the scalar potential. You can go and check it now. How you will calculate scalar potential? एक बार check करके देखो. This is the scalar potential. V is the scalar potential, and this E is a vector potential. This thing, right? So, and you do follow the classes and all regularly. And as I told you now, in the Telegram, you do message me here. You can search at B V Reddy in the Telegram. B V Reddy. You can search and you do message me in this Telegram. I'll share the DPP short notes, problems. I'll share you. Yeah, that's for the today's session, and we'll meet in the next class. Next class we'll see some problems. We'll see. Thereafter, these are some problems. Thereafter, we'll start the static field. Will start. Okay. Fine. Okay then. See you. Bye bye. Take care. Good night. Tomorrow same timing at tomorrow same timing at 9 o'clock we have a session.